we are going to attempt the past paper questions related to chemical bonding. So first of all, we have a question: in which of the following pairs is the first element expected to have a higher electronegativity than the second one? So first of all, lithium. Lithium is what happens. Lithium is present here. Lithium is having Li3, while beryllium is Be49. So what happens, you can see it has greater nuclear charge, so that is why it must need to have greater ionization energy. So it has greater ionization energy because of greater nuclear charge. As we know, ionization energy is directly proportional to nuclear charge. So because of this, what happens, beryllium is going to have greater ionization energy. So this one is going to be false. While magnesium and strontium, they belongs from group 2, and in group 2 magnesium is present above, strontium is present below. So we know ionization energy, as we move across the group, ionization energy decreases as we go down the group. So what happens, because of that, magnesium would have higher ionization energy as compared to strontium. So B is the right answer. While if we see beryllium and aluminium, their electronegativity is 0.7 and 0.7, so there is not much difference, so this is also false. While if we see bromine and chlorine, they belong from group 7, so it is going to be fluorine, bromine, chlorine. So you can see that chlorine is present below. So what happens, that oh, no, basically it is going to be like fluorine, then chlorine, then bromine, then iodine. Yes, this is the right arrangement. So you can see that chlorine is present above, and we have seen ionization energy decreases downwards. So chlorine is going to have greater ionization energy. So as this is going to have greater ionization energy, so this is also false. Now moving towards the next part, they are saying to us which of the following is non-polar molecule containing polar bonds. So first of all, if we see CH3, 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 carbon and hydrogen, their electronegativity difference is approximately equal to 0.4. So their electronegativity difference is approximately equal to 0.4, which makes it non-polar. So these bonds are non-polar bonds, and they are symmetric. Why they are symmetric molecules? Because CH3 is here, CH3 is here, so they are not like having any kind of polarity there. They are not pulling the electron more towards one side. So what happens, because of that, the electron remains intact, and that makes them symmetric. And because of symmetrical molecule, it is going to be non-polar molecule. It is also non-polar molecule. Okay, that is non-polar molecule. So this is non-polar molecule and having non-polar bonds, so this option is incorrect. If you see B part, then what happens, this is CH3 and this is CF3. Here carbon fluorine bond is polar bond because of the difference in electronegativity is greater than 0.4. So it is going to be a polar bond. While if we see the molecule, then molecule is going to be, this is CH3 and this is CF3. So it makes the molecule polar. Why molecule is polar? Because CF3 being more polar, what it is going to do, it is going to induce a partial negative charge here, partial positive charge here, because it has polar bonds. So this makes the molecule polar molecule. So this option is also incorrect. While if we see CH2, double bond CH2, then it has non-polar bonds, while the molecule is also non-polar molecule because it is also symmetric. Non-polar molecule because it is also symmetric. So this also option is incorrect. While if we see these options, we know CF bonds, they are polar bond, while it is also symmetric because same atoms are on both sides. They would cancel out the polarity effect, and what happens, the net dipole moment is zero, which makes it a non-polar molecule. Remember, it is always symmetric, and the other thing is going to be, as it is symmetric, and it has no net dipole moment. So this option is going to be the right one. So the next question, which of the following molecules are paired correctly with their property? C2H6, it is basically a non-polar molecule, and non-polar molecule, as they don't have free moving ions, so because of this they do not conduct electricity. So this option is incorrect. And then calcium chloride being an ionic compound, and we know ionic compound, as they are going to have strong electrostatic or coulombic force of attraction between ions, and ions are cation and anion. So because of this they must need to have high melting point, as they are saying low boiling point. So it is also going to be wrong. Then if we see NH3 molecule, they are saying it's poor conductor of electricity. It's absolutely correct because it is a non-polar molecule. And what happens because of that? Non-polar molecule, and it is covalently bonded, no free moving ions, and because of no free moving ions, what happens, it is a poor conductor of electricity. So this option is correct. While they are saying copper chloride, which is an ionic compound, and most of the ionic compound, they are soluble in water because they develop ion dipole forces with water. So because of that they are soluble in water. So this is also incorrect. Then they are saying which statement is true about metallic solids. So if we see metallic solids are cations, and they are basically surrounded by sea of delocalized electrons. They are surrounded by sea of delocalized electron, and there is a strong electrostatic force of attraction that is present between cations and sea of electron. So there is a strong, you can say, electrostatic or coulombic force of attraction that is present between cations and sea of electron, and because of that it is going to have high melting point and boiling point, sea of electrons. So option C is going to be the right one, which is telling that it is going to have attraction between positive ions and delocalized electrons. Why we say them delocalized electrons? Because they are freely moving electrons, and metals conduct electricity because of them. Then in the next question, which of the following should be considered when determining the Coulombic force between ions? So Coulombic force of attraction formula is going to be K into Q1 Q2 divided by R square. These are the charges, and these are the distance between the particles, or the distance between ions. So they are saying which of the following should be considered when determining the Coulombic force between ions. The charge on the ions, that is absolutely correct because it is dependent on the charge of the ions. Then the mass of the ions, it's incorrect because it doesn't depend on the mass. Then the distance between the ions, it's absolutely correct. So the option is going to be 1 and 3. So answer is going to be D there. Then they are saying which of the following is likely to have the least ionic character. So if we have to do this question, we must need to have the electronegativity differences between them. Why? Because you must know it, for for example, least ionic character is going to be, for the electronegativity difference is going to be the minimum. So if we want to see the electronegativity difference of boron, that is 2.0, and fluorine is going to be 4. So its electronegative difference is 4 minus 2, that comes out to be 2. Then for nitrogen and carbon, carbon is 2.5 and nitrogen is going to be 3. So their electronegativity difference is 3 minus 2.5, that comes out to be 0.5. Then we have magnesium and oxygen. Magnesium is 1.2 and oxygen is going to be 3.5, and their electronegativity difference is 3.5 minus 1.2, that comes out to be 2.3. And then silicon is going to be 1.8 and chlorine is going to be 3.0, and their electronegativity difference is 3.0 minus 1.8, that comes out to be 1.2. So the least ionic character is going to be the one which is going to have least electronegativity difference, that is going to be B. So in this question, they have drawn a graph between the potential energy and internuclear distance. So what happens there when two atoms, they are at a distance, their potential energy is going to be minimum. So here potential energy is basically minimum. And then what happens when they forms a bond, when they forms a bond like this one, and electrons are present here. So when they form a bond, then what happens at this place? This is nucleus, this is nucleus, and here we have the force of attraction. Here we have force of attraction that is present, force of attraction between nucleus and shared pair of electron, shared pair of electron. But what happens when they come more closer? Here they are coming more closer, then what happens? This nucleus and this nucleus, they have both have positive charge, both have positive charge, so they starts to repel each other, okay, because of positive charges on nucleus, they start to repel each other. And what happens? Potential energy becomes too much high there. And here what you are going to see, they are saying as two chlorine atoms approach each other, there is a decrease in energy. This decrease is because of, first, there is force of attraction that is developed between nucleus and shared pair of electron. What they are going to do at this point, this is greater than the repulsive force which is present here, repulsive force between oppositely between like positive charges on nucleus due to the repulsive force that occurs because of the positive charges on nucleus. They are going to repel each other. So at this position, this force of attraction is going to be greater than the repulsive force between positive charge on nucleus. So our answer is going to be C there.